This is Group 34, Vista. That's the Vent Intelligent System for Temperature Adjustment. We're composed of 3 EEs, myself, Alex Satalias, Isabella Polke, and Katarina Brown, along with 1 CPE, Luke Morrison.
Vista consists of 3 PCBs. The first is the power board, which takes power from a 9-volt battery and uses 2 regulators to step it down to 5 volts and 3.3 volts. The separate power lines are then fed to the main components board, which consists of an ESP32 that receives code through UART and USB bridge. The microcontroller can then read and respond to environmental conditions presented by temperature, humidity, and occupancy sensor readings. The occupancy sensor is its own PCB that has a separate housing structure. The idea behind this design is that the occupancy sensor can be tilted as needed in a given space in order for the lens to view an entire room. Once the ESP32 receives data from the sensors, the information is used to power a servo. This servo works in conjunction with a rack and pinion system that converts the rotational motion to linear. The housing structures, vent, and rack and pinion are all 3D printed to allow for precise cutouts and durability. Everything is mounted to our demo wall, which consists of a sheet of drywall and some 2x4s. The Vista vent is placed over a pre-existing wall vent, which you can see is right underneath. Depending on the conditions present in the space, the ESP32 sends a signal to move the servo, and in order to adjust temperature and humidity, the vent will open or close.
In this section, we will discuss the various software components that make up the Vista device. To begin with, the Vista will need to complete the device initialization process. In the device initialization process, the user will provide a valid Wi-Fi login and will also create a user account for the web application. This is a video of the Vista device upon startup. Since this is the first time the device has been turned on, the user will need to begin the device initialization process. This is done by connecting to the Wi-Fi access point network named Vista Access Point with a pre-programmed password. Afterwards, the user will open a browser and type in a specific IP address. This will load the device initialization page. This is the main page of the device initialization webpage. Here, the user will enter the Wi-Fi SSID and password. If the Wi-Fi network the Vista will register as an enterprise network, the user will check the enterprise box and enter a corresponding Wi-Fi username. Since this Vista will register a non-enterprise network Wi-Fi, this box will be unchecked. After the user hits send credentials, the Vista will receive the configuration and attempt to connect to the Wi-Fi network. If successful, the page will redirect to the account creation page. Here you can see that the account created is successfully registered, where the web app will begin immediately attempting to connect to the Vista device. In this web application, you will be able to control the device settings and also have live readings of the temperature, humidity, and motion detection. Here is a video of the live temperature and humidity readings from the Vista sensors. This is located on the home page of the web application. From the web app, all aspects of the Vista device is controlled. By simply navigating to the device configuration tab, the user can control the temperature and humidity maximum and minimum values. The user can also manually control the vents by disabling the default setting. By disabling the default setting, the Vista will no longer open or close the vents based on temperature, humidity, or motion detection, and will instead be manually controlled by the user. Enabling default will have the Vista open or close the vents based on the sensor values. Finally, the user can toggle the status of the eco mode switch using the provided toggle switch. When the switch is off, the device is inside of vacant mode, and when the switch is on, the device is in eco mode.
There are 3 different scenarios that the Vista can encounter with a user. The first is based on temperature, the second on occupancy and humidity, and the last is based on user preference. The first scenario, the temperature scenario, utilizes the eco mode on the Vista. As you can see in this video, the temperature range is set by the user. This can be set and kept for everyday use. A finger is then placed on the temperature sensor so that it exceeds the user set specifications. This causes the vent to open and create more airflow in the room. Once my finger is removed from the system, it thinks the room is too cold and will then close the vent to warm up the space. Eco mode is intended to be used every day within a home. The second scenario is based on the occupancy and humidity sensors. This mode is called vacancy mode. The idea behind this mode is for when users are out of town and care less about the temperature settings within the home. The user can configure the temperature and humidity specifications for vacancy mode to ensure minimal energy usage is used. The vacancy mode ensures that the temperature and humidity within the home stay within a certain range as the user specifies. As you can see in this video, the humidity is way below the set range, so the vent opens to allow more airflow and decrease humidity in the room. This can also be used in the opposite scenario. The final scenario is based on user preference alone. The web design gives the user options to turn off default mode and open or close the vent automatically. As you can see in the first scenario, Luke is drenched in sweat sitting in a very warm room. He wants to get cool fast and can't wait for the room temperature to slowly adjust. So he forces the vent open to allow more airflow. Once it opens, he is much happier. In the second video, I am way too cold in the living room. In this scenario, I also cannot wait for the room to slowly heat up. So I want to close my vent quickly and stop the air from flowing in. Once this happens, I am much happier and warm.
The PIR sensor is able to consistently detect motion. It is a bit sensitive, however, it is able to consistently respond, as you can see on the oscilloscope, to human activity or motion in front of it.
The second demonstrable requirement for Vista is for the vent to open or close within 1 minute. We demonstrate this by utilizing the force open or close option on the web app. As you can see by the first trial, the vent closed in about 8.2 seconds. In this second trial, the user once again wants to force close the vent in order to restrict the airflow. This can be to either lower the temperature or humidity in order to combat the current conditions in the given space. In this trial, the vent ends up responding in about 11.5 seconds. Differences in the time can be attributed to the size of the queue that the vent has built up of other actions to take. If there are other tasks that have been requested first, they will be completed in the order they are presented. So if a request is sent to either open or close the vent by the user, the amount of time it takes to complete depends upon the number of tasks already in the system and how long those tasks take to complete first. Due to this, the third trial shows a longer response time of opening the vent of about 23.7 seconds. All the trials are completed in under a minute, which achieves the requirement with an average close or open time of 18.69 seconds.
Our third specification requirement is for a user to consistently establish a connection at least 50 feet away from the Vista. This ensures any user can integrate their device to their home network for any realistic environment. Here, you can see Katya and Luke conducting our first trial, which ends up establishing a connection at exactly 56 feet. We're able to successfully connect to the page hosted locally on the ESP. Our second trial again aimed to exceed 50 feet, which, just for a little context, we're using the app shown here to measure the distance from the starting point. It utilizes GPS and cellular triangulation to measure exactly how far we move from the starting point, which you can see ends up being exactly 61 feet. We're still able to make a connection to the ESP and see that webpage. Next, we wanted to see the absolute limits we could push the connection range to, which you can see we made our way down into the parking lot. Oh, there I am. Hey, Alex. So from this distance, we measured it to be about 75 feet, which you can see us loading the webpage here without an issue. Oh, hey, Bella. Next, we found out the absolute limit we could go was about 412 feet, although the GPS tool we used gets a little inaccurate or imprecise at that distance. it's very sad to see it finally disconnect, but you can see we walked quite a distance all the way back to the base station of the Vista device.